In this video, we're going to be talking about topics 5A and 5B. In topic 5A, we're going to be looking at the difference between inductive and reasoning, while in topic 5B, we'll be talking about conjectures and counterexamples, and we'll be doing some discussion in this video about how each of these things is important to the work we're doing here in our geometry classes. Inductive reasoning is the process of patterns, observations, or specific examples from small groups to draw general conclusions about larger groups or populations. Okay, so I've got a diagram to kind of illustrate what we're talking about. Okay, with inductive reasoning, we're using information that we've gotten somehow from a small, and we're using it to draw a conclusion about some larger group of people or things. Okay, so an example that we could look at would be if we said that West Springfield student population of students that are white. Okay, keep in mind these numbers are not necessarily accurate, but let's just assume for this example that they are, and we're taking this as a given. If we said that 55% of West Springfield High School students are white, and that West Springfield High School is a public high school in Fairfax County, then we use inductive reasoning to conclude that all public high schools in Fairfax County must have student populations that are 55% white. Now we're going to see in when we get to topic 5B and we start talking about conjectures and counterexamples why it work. Okay, but without getting into any more detail on that right now, the important thing to remember about inductive reasoning is that it is a valid form of proof. Inductive reasoning is not, okay? If we're going to use some sort of reasoning that we can use to prove things, or that we can use as a valid form of proof, then we need to talk deductive reasoning. Okay, deductive reasoning is the step-by-step process of using logical reasonings to draw conclusions based on previous known facts. Okay, now this is different from what we did in inductive reasoning, because where in inductive reasoning we were using a small group or information from a small group to make generalizations about a larger group, here it's the other way. Here we're taking information, we're taking previously known facts we have from a larger population, using it to draw a conclusion about a smaller group. Okay, particularly noteworthy here. Unlike inductive reasoning, deductive reasoning is a form of proof, and you guys are going to see why inductive reasoning and particularly deductive reasoning, is important to us as we get into some of the work when we get to topic 6. In topic 5B, we're going to be looking at conjectures and counterexamples. So what are conjectures and counterexamples, and why do they matter to the work that we're doing here? A conjecture is an educated guess that is so. If you think back to the example that we were just considering with our student demographics at West Springfield High School, known information that we have would be that 55% of West Springfield High School students are white, and that West Springfield High School, again, excuse the numbers, don't know that they're definitively factual, but we're accepting them as givens for right now. So, a conjecture based upon these previous facts would be that all public high schools in Fairfax County, public schools, must have 55% white student populations. However, I said a couple seconds ago that inductive reasoning is not a valid form of proof. Okay, the fact that we've got a small example, okay, or an example taken from smaller sample sizes, does not allow us to accurately generalize those findings to a larger size, and that's what we're doing in inductive reasoning, is we are using previously known information to come up with a conjecture, okay, an educated guess that is based on known information. But Justice, which is also a public school in Fairfax County, is only 22% white students. This is an example of a counterexample. Okay, a counterexample is a special kind that disproves a statement, proposition, or conjecture. Okay, counterexamples are how we show a condition. Counterexamples are specific cases where P is true but Q is false, and they are used to disprove conjectures.